Hello there, this video is for chapter 9, 9.1 in Pre-Calculus 30, talking about rational functions. Here's number 8. Okay, number 8. So this one's a bit of a tricky one here. It says the rational function y equals a over x minus 7 plus k passes through 2 points, 10, 1 and 2, 9. And it asks you to determine the values of a and k. Okay. Well, we have two missing pieces here, so it's not as simple as plugging in a point in 10 in for x, 1 in for y, and solving for the missing piece because we have two missing pieces. But we have 2 points, so we can kind of play one off the other, and I'll show you what I mean there. So what we're going to do is we're going to write two different versions, really, of this equation with the points included in x and y. So y is 1 when x is 10. Okay, now we still have two unknowns, but if we do this twice, you'll be able to see what happens. Okay, so 9 is the y, and we have a over 2 minus 7 plus k. All right, so if we do that, what we can do is we can solve for one of these variables, either the a or the k. The k is all by itself, so I'm going to solve for k over here on the left. What is that going to give us? It's going to give us a over 3 plus k. So 1 minus a over 3 equals k. All right. Now what that does is it puts k in terms of a. And if I take this whole thing right here and substitute it for k over here, then I'm going to have an equation with just one unknown variable. And we can do this because really it's the same graph, right? So we're giving a version of the expression with one point that's on the graph, and then another version of the same expression with another point that's on the graph, so they are linked. So we can combine them together. So that's what we're going to do. I'll change to blue here now. So 9 equals a over, what's 2 minus 7? Negative 5. Plus, what do we have over here? 1 minus a over 3. Okay, so now we have an equation. All right, it's not a nice little neat equation, but it's just an equation with one unknown variable. So now we can solve. What I'd like to do is probably get rid of the denominators. So I'm going to multiply by negative 15 because that's going to get rid of the 5 and the 3, the negative 5 and the 3. And so negative 15 times 9 is negative 135. And negative 15 divided by negative 5 when I multiply by this one is that's going to be a positive what, 3? So 3a. This one is minus 15 when you multiply this by 1. And negative times negative is positive. 15 over 3 is 5. So this looks like 5a. 3. Okay? I think that's good so far. So let's solve for a now. Okay, so let's add 15 to both sides. I have negative 120. I have 3a and 5a is 8a. So a is negative 15 when you do that division. Oops. 8a. Nope, just a. I don't know why that disappeared. See that? Just disappeared on me. Glitching. This is probably going to actually, the program is probably just going to crash on me soon, just so you know. Okay, so if a equals negative 15, so that looks to be like the first bit. And then I need to solve for k. Well, that's easy because I've got a here, and I can just solve for k. So k equals 1 minus negative 15 over 3. K equals 1, that's going to be a plus. 15 over 3 is 5. So k equals 6. And those are your two answers for a. Okay? So that's a. Now b, graph the function. It's not too big of a deal, I don't think, because really the function looks like this now. We have negative 15 over x minus 7 plus 6. Okay? So we can look at this and say, all right, my vertical asymptote is moved over to the right 7 units. So let's say, 1, 2, 3, 4, 5, 6. Let's go by 2. 2, 4, 6, 7. So here's my new vertical asymptote, if that makes sense. If that makes 7. So there's x equals 7. And then the horizontal is up 6 units. So let's go 2, 4, 6. Okay. And so we have, there's our two asymptotes. And a is negative, so instead of the graph looking like generally like this, a being negative, that flips around. Okay, so the graph is going to look kind of like this. It's going to have lobes kind of like this and like this, roughly. All right. But let's plot the actual points to make sure we're good here. So 2, 4, 6, 8, 10, 1. Oh, I was pretty close. Oops, come on now. 10, come on. 10, 1. And 2, 9. So 2, 2, 4, 6, 8, 9. Oh man, I'm really close. Okay, so basically, you know what? Give me just some kind of rough drawing with these through there, and we'll be kind of good to go. Okay. So that's kind of how you'd graph that. Okay. So that's number 8.